taking a look at equations that have special solutions. We have two basic special solutions here. We're going to come across them in different forms during this year as we're working through linear algebraic equations. But these are the basics. They look slightly different depending on the situation. But here's what we end up with. So I have negative 4x plus 15 plus 6x minus 2 equals 1/2, and then parentheses, 32 plus 12x, close parentheses, minus 1 minus 6. So let's simplify each of these sides and see what we end up with. So my left side, 15 plus 6x minus 6x. The plus 6x and the minus 6x cancel each other out. I'm only left with 15 on the left-hand side. On the right, I'm going to distribute here. So 1/2 times 32 is 16. 1/2 times 12x is 6x. And this minus 1 minus 6x come along for the ride. When I start to simplify this, I can combine like terms and get 16 minus 1, which is 15. And then the 6x minus 6x cancel each other out. They're additive inverses, so I have 0. And I get 15. My variable's gone. Like, it's gone. So I don't have a solution here. And I've ended up with two sides that are equal to each other. So what that means that it really doesn't make any difference what number I pick for my variable. If I picked 1 and plugged that in here, I'd get both sides. 1 would work. If I picked 10, 10 would make the two sides equal to each other. If I picked 20, 20 would make the two sides equal. If I picked negative 1,000,000, it would make the two sides equal. So the solution to this is all real numbers. Pick any real number that you'd like, plug it into this equation, it's going to work. So if I think about my replacement sets, I can pick any number. Any replacement set is going to have all those values work for it. Now let's take a look at another example. So I have negative 3y plus 10 plus 2y plus 1y equals 4, and then in parentheses, 2x plus 2, close those parentheses, minus 8x. So let's simplify each of these sides. So on the left side here, I can put together my 2y and my 1y and get 3y. And then the negative 3y and the 3y cancel each other out and leave me with just 10. On the right side, I need some more distributive here. 4 times 2x is 8x. 4 times 2 is 8. That minus 8x comes along for the ride. So I end up with 8x and minus 8x cancel each other out, and I'm left with 8 here. Notice variables are gone again, and I'm left with two values, two constants that are not equal to each other. So it really doesn't make any difference what number I put in here. I'm never going to come up with two sides that are equal to each other. Doesn't really make any difference what happens. They're not going to be equal to each other. So there's no number that I could use that would make this work. So we say no solution here. So when we're thinking of special solutions, if you think you're coming across an equation that has one of these special solutions, I highly suggest that you continue along until you can make the variables disappear. Once you've legally made the variables disappear, what's left? If you have two numbers that are clearly equal to each other, your solution is all real numbers. And if you have two numbers that are clearly not equal to each other, there's no solution for that. So we can write no solution. We could also use the null set symbol.